Welcome, ladies and gentlemen, to our DLG forum, Feldtage Digital of the DLG, here now from Frankfurt. I know that DLG-Feldtage, so the field days on open air trade fair, could not take place because of Corona, you know that. However, we now use that time to go in detail for some specific topics, and we have the time to speak now. This is even better sometimes as in the field. However, this is not a substitution of DLG-Feldtage, but it's only a bridge for next year. Now to look on some specific topics, and next year we meet personally, shake hands, and go through the field and see all the methods for crop production which will be offered in that time. Well, traditionally, DLG forums are for discussion specific topics with some experts, and this will be done in this hour as well. You actually can join the discussion by using the button on the lower side of your screen with Q&As. You can really go into there, put in some questions from your side, and a colleague of mine, Alexander, is here in the studio and will read them out loud, so everybody will hear them, and we can discuss it later on in the discussion around about 30 minutes from now. For me, my name is Klaus Edle from DLG Competence Center Agriculture, and I will lead you through this forum for the next 40-50 minutes. Our topic for this hour is Science Fiction Becomes Reality, Robots in Mechanical Weeding, a very sophisticated topic, but let's see what's behind it. So farmers nearly in every region of the world, South America, North America, Europe, also in Southeast Asia, struggle with the use of herbicides or herbicides in crop production. So some herbicides are not working anymore, the others are not allowed anymore, and even the society do not accept herbicides like glyphosate anymore. So what to do? We were lucky, and the technological development sped up the last years, and a number of really good solutions for mechanical weeding came up and are already well used by farmers. Even more, technology allows us now to develop or use machines who run autonomously. So without a farmer, without a driver sitting on top and steering the machine, they run like robots in the field. But still, this is not common practice yet, but we see already some in Europe running, France, Germany, Denmark, and so on. We see tests in the field where those systems are really tested on farms, and they work, or sometimes they do not work with some failures, but for such a young technology, this is quite normal. And I want to discuss this topic with experts I invited in the group. And my first guest is Beat Vincent. Beat studied agronomy at the Technical University of Munich. Also there he did his PhD. And since a few years, he's working at the Bavarian State Research Center for Agriculture with a strong focus on digital solutions on farms and for farmers. And he always has the questions, what is the solution for the farmer? Is it good? Is there any benefit from the farmer side? And Beat, we met, I guess, 3 or 4 years ago on an international research project. And this project had a focus on the question, why do farmers not adopt all the smart farming tools available on the market? Why do they not buy it? So the tools are so smart, so handy. So why do farmers still work with old machinery? And well, we had no final solution out of that research. It's still going on. And the obstacles for adoption of new technology is still going on. But you are one guy who is very close to farmers and to the field, and also testing and evaluating technology. So what are the first biggest questions arising when you talk to farmers about robotic and autonomous vehicles on the field?
Okay, yes. Thanks, Klaus, for the introduction. I hope you can hear me. Since 2018, robotics in weeding is one of our main research topics in Rostock when it comes to digitalization in agriculture. And yeah, the focus is on evaluation of the new technology and the knowledge transfer to the farmers. We do this by field trials, demonstration days, and so on. And yeah, why do we do this? Our vision behind this is that these small and smart robots can help the farmers to be competitive in the future and build up climate resilient farming systems. So yeah, that's so far for the vision, but there's a huge but. And we often discovered that realities is, it was also, you mentioned, it was figured out in the Smart Arcus project, is that often these SFTs, these smart farming technologies, they are often neglected, especially by small farmers. And they often feel that companies do not consider enough the needs of the smaller farmers. Often also the robots are too expensive, they're too complex. But yeah, there would be a really interesting technology, especially because the small robots are also scalable to small farms. And yeah, so we hope that in future there's a good concept that don't have to be the most complex and most expensive technology,
maybe
and also can be successful.
Not cut, Bert, we will cut your video and only for voice because your connection is not that good. So to get out the pressure of the pipe. So now you're still online and can talk to us still.
All right, so I think I start from the beginning.
No,
sorry
start,
for
just
the bad connection in Lower
we heard
Bavaria.
We heard the most of it.
Okay. Yes, so the question is how the companies can get it to build smart and small, but also not too complex and not too expensive robots for farmers to build up this resilient and competitive farming systems for the future, we think.
That's a great question. Let's directly direct it to the guests I have in the back or on the video as well. So we've invited we invited different representatives of companies who really offer or work with robotics. And the first one is Christian Raming and René Jørgensen from FarmDroid from Denmark. So Christian Raming is an educated electrician and engineer, and he soon worked with his brother actually on developing robotics for agriculture. And they founded the company FarmDroid in 2018, so not 2.5 years ago. And next to him, there's René Jørgensen. He's also a very educated engineer and joined the company this year. So a very young company with very fresh people behind. So to the two of you, can you explain FarmDroid, what the ideas behind, and do you have actually a product which also works for small farms, and what are the advantages of it?
I would like to say thank you, first of all, for inviting us for this interesting topic. You can say FarmDroid is a product coming out of an agricultural family where one of the founders saw the problem in the field of mechanical weeding, that it was done by hand. So he wanted to do something more smart, more clever, and suiting smaller farmers. So our machine is designed for fields up to 20 hectares capacity, but can also be used on numerous fields. So if you have 4 fields of 5 hectares, you can move it around during the season. We actually already have more than 500 robots running in Europe. So there is actually a commercial product. This year, we're actually running with a good deal of them in Germany. And we have good results, and we have challenges adapting to a new environment, different soil types, and then a very dry spring. I actually have prepared a presentation. If I can share that.
Yeah, go ahead.
So 2 seconds and I'll be there.
Yeah.
I can see it's disabled from your side.
I will have a look at my technicians enabling a presentation. He's working on it.
Okay.
Now,
so
do it. You're free to present.
Good. Just share here. So let me know when you can see my presentation.
We do see, but we still need the presentation mode.
Do you see presentation mode now?
Not yet.
It's,
no.
Not yet. I think there's a slight delay on the connection.
Maybe.
That's why we tested this in advance. 2 seconds. I'll just try again. How is it now?
Oh, now it works. Perfect.
Okay. I've already mentioned a bit of it, so I'll skip fastly into the presentation, skip the agenda, and go to the history of FarmDroid. Actually, the concept is back from 2011, where you see this rusty solar cell-driven robot in the lower left corner. This was the first prototype. It was a part-time, study and science project by Christian and his brother, who founded FarmDroid in 2018. In 2018, we had the first version of the robot running in Denmark, and collected a lot of experience developing a version 2 of the robot, which are now running in more than 6 European countries here in 2020. We have actually seeded and cleaned, weeded more than 1,000 hectares this spring. I have a small presentation video that will show you actually what the robot is capable of. I'll try to speak over it, so hopefully you can get a bit more information. So the concept is that it's an automatic seeding and weeding robot. The robot is solar powered, so powered by 4 solar panels and a battery backup bank, which actually give us operation of up to 24 hours without any external charging. We seed using a geo-coordinate seeding system that provides millimeter accuracy. And if you see it from a horizontal level, we actually make a very fine seeding pattern where you can see the lines in all directions. The weeding that is performed with the same high precision navigation, both between the rows and in the rows, so we can minimize the need for supplementary manual hand weeding. And that's the whole concept, to free up the farmers from this hard repetitive work of doing manual weeding. The robot can actually be left, if you have a 20-hectare field, be left there for all of the season and then brought back to the farm and made ready for the next season. So that's kind of the philosophy around it, that you only move it if you need to get to another field. Otherwise, you just leave it out there and it will take care of the field for you. Oh, no, I skipped the presentation completely. The functions of it is that we have a single out or portion seeding configuration. It's initially designed for sugar beets, but we actually already this year have a variety of 4 crops that we seed. So we can make single seeding or portions varying depending on the farmer's needs. Usually we have 6 active seeding rows on the robot, but we can actually configure up to 8 or more based on demands. We use an RTK compensated GPS system that actually gives us an accuracy of around 8 millimeters. And that is the essence that we do this very exact, precise seeding, as you see in the picture here to the right. And that means that we can actually already start weeding before the crops is out of the soil to keep the competition from weeds very low, so we give the best possible conditions for the crops. I mentioned a bit of facts before that is solar powered operation of up to 24 hours depending on weather condition and soil types and hills. We drive at speeds from 450 to 950 meters per hour. So compared to traditional farming equipment, we drive with a lower pace, but we drive for a long time, and that's how we get our capacity of up to 20 hectares. I think I dropped out. How much did you get of my speech? I think I lost sound.
We lost only a few seconds, only 2 to 3 seconds of your speech. Everything fine. Okay, thank you. But as mentioned, we have a rated capacity of 20 hectares, but coming on the market with a new product, farmers also stress tested. So some have success with having the robot taking care of a quite bigger area than the 20 hectares. So that's the predominant functions of the robot. If I go to some of the experiences, yeah, then we'll give experience this year from more than 6 European countries, and learnings from more than 500 farmers. And these learnings are really essential to us because we've designed a product, but the farmers have a lot of ideas and suggestions for how we can actually adapt it to their application, but also develop it further so they get additional and higher value of it. I'll not take you through all the statements here. I'll rather try to raise some questions for further discussion. And one of them is, how do the other participants actually seeing robots being further integrated in the agricultural value chain? What could be the challenges and what could actually be the gains? It could be both smaller and bigger farmers. We base our product on 20 hectares, and if you want to scale that, then you need additional robot rather than a bigger robot. But is that an advantage or that's a disadvantage? And then there's a question around the climate and the development we have today. And that is, which technologies are actually needed in Europe to ensure that we reach the goals for reducing chemicals in agriculture? I think we have a lot of opinions about that, but I'd like to hear in the debate later what the feedback is from the farmers. That's very good. Thank you for your short presentation. It's really impressive and perfect that you already come up with some questions we really can address later on. But before we talk about those questions, I also want to invite Christian Kirchhoff. He is CEO of the company Cult. And in strong contrast to FarmDroid, Cult is already very long on the market and has a lot of experience. Christian Kirchhoff is also an educated agronomist, and he studied at the University of Applied Sciences in Nürtingen, thus in Germany. And since about 20 years, he's working on mechanical weeding tools. And he really followed the way of the technical, or the old style mechanical weeding up to now robotics, and had all generations of technological evolution behind him, so to say. And it would be now very interesting where he sees now the status quo in compared to 20 years before, and where he sees the future of robotic machines in agriculture. Mr. Kirchhoff, the stage is yours.
Thank you very much. I hope you can hear me.
Yeah, everything fine.
Very special setup out of several places. Yeah, I would say hello. Thank you for being with you. I think I will just start with a short presentation about exactly what you were describing, Klaus, our way from the beginning, starts like 2001, to where we are today. I try hard to make it working. Sit back, take your seatbelt on. I do it fast. Can you see that?
Not yet, but we are working on.
That's bad.
You have to share screen in the middle of your screen somewhere. Should be bottom sharing screen.
That's a good idea.
We will make it work. Yeah, looks good. And now in the presentation mode, and
okay,
it should work. Yeah, perfect.
Should work?
Yeah, working.
Thank you. Short history of the company. The company was founded in '85 by a farmer, Walter Kress. He was, and I do the German here for the German visitors in the text, and I'm gonna speak English for all our international visitors. I hope that applies. He started to build machines for the organic movement, which has experienced a big increase in '85 and '90. So it was more or less technique from farmer to farmer. He got so busy that he started a business in '89 as a company together with his brother and others, and was more and more involved in distribution and construction of weeding equipment, hoeing equipment at all for organic farmers, special crop growers, including the nursery business, which was very important at this time. Myself, I started in '91 in this company, so close to 30 years now, in the same company, in the same business. I took over the shares in '97 as Mr. Kress left the company to run his own farm, 100%. And since this time, we are more or less in the organic weeding business, and should maybe explain for foreign visitors that especially the weeding in conventional farms compared to other European countries was for a long time nearly not used at all. So we have customers in France which are totally common with weeding equipment, even conventional farmers, but in Germany we had many farmers not even, they knew nothing about it. So we have a total new development, and Vincent, Mr. Vincent knows exactly what I'm talking about when he's doing his field days and presenting total new stuff to some farmers which should know it from their grandpa. So we started in 2001 with our first system where we bought an Ecodan camera system, which is today distributed by Klaas, and made our first experiments. At the same time, I was looking around also in the Netherlands for robotic self-propelled vehicles and stuff like that. Soon we sold our first camera steering in 2003, really in the field. On this image here, you see a marker row. The system was working only on one line, and if the line was missing, we were in need of some other better guiding. So we were sowing a marker row in between the sugar beets, which was killed after the second pass in the field. That's the image of the camera system. Soon we also sold the first triple bed camera system. This is 3 independent elements for vegetables, where bed by bed 5 rows are transplanted, and the cultivator can do 3 beds at the same time. This is all done with a camera system and side shift. 3 independent side shift elements. And if we are lucky, the film is running. Is not. Why ever? The technical guys can maybe help me. What am I doing wrong? I think I cannot manage to make the films running.
So it's not possible from here as well. So maybe we can look at the picture and you tell us about it.
I just described the system. It's a triple bed machine where 3 independent beds are cultivated at the same time to increase speed by a lot. Interesting here is that the tractor had also a GPS system and ultrasonic tracking system. In theory, that was one of the first robots, if you want to say, but the farmer was not allowed to use it really, and still not. Because we have GPS systems, we have automatic headland management, we can easily design a field map for a tractor like this. We can automatically lift and lower the implements. We can steer the tractor by GPS or other guidance system like the ultrasonic sensors in front of it. And the camera system will steer the hoe behind. So normally there's no driver necessary at all, but we do not have the laws to allow that at the moment. I cannot go through it. Can you see that now? Yes. In 2006, we started with the distribution and mounting of a very high precise GPS system. It was from the company Autofarm, later it was Egg Leader, into tractors with the goal to steer implements. So we were steering seeding and transplanting machines and then running the cultivator behind. You see the double antenna here. That was a system with 2 antennas to identify a way of travel of the machine and slope situations immediately. So we could work very good with this system. We found later out that we will not continue with GPS solutions as manufacturer of hoeing equipment. But for us, it was a very interesting experience. On this image, you see disc steering of a bed shaper, where we could follow later with the same GPS signal again with the cultivator. Not very much later, we started with field testing together with Mr. Pausen, a little company out of Denmark, engineering company, in-row weeding equipment. You see here one of our first prototypes for 1 row. And since 2007, you can say we started really to collect knowledge about in-row weeding equipment. I try again if I can show you a film, if we are lucky. Can you see that? You cannot, I think. I'm sorry.
No, it's not working. No videos.
Yeah, I saw so. No videos. It's okay. We have more time for the discussion. So, this in-row machines with a line scanner system detect plant row by plant row the plants and their diameter, and they differentiate between size of plant and size of weed. The wheel behind you see is a speed wheel to measure the speed of the machine. So we have a very good knowledge of the distance between the camera and the plant where the tools work, related to the speed of the machine, or even when we stop it and go ahead again. We should not forget other weeding tools, which are, and I would say everybody thinks with robots about electronics, but we should not forget to work also with robots, with traditional tools, wherever it's possible. On this image, I show the precision of tools, or what is possible and how close you can work beside the plant row when you have a proper steering. On this image, it's either achieved by a camera steering or, and I assume by a hand steer. I cannot tell you really, but I can tell you that we are in the cultivator business selling like maybe 100 hand steered machines per year.
So Christian, maybe we could speed up a bit because we have still 8 years to go and we already used a quarter of an hour. So
still about the precision. I still state precision is very important, and that's also important for the robots. You see the weedings tools we're doing as cam steering. Today, we do a lot of research. That was a research project with the University of Hohenheim, where we did 2 3-meter cultivator with camera steering on very close row distance of 12.5 centimeter, 15 centimeter. We also work and sold machines of the company Nayo out of France. That is a totally autonomous vehicle with tools working in between the plant row. It's guided by camera or GPS. There are small and bigger machines available. We have experience with approximately 10 or 12 machines in the field. And we support the company worldwide with tools which they mount in their robots. We are doing cam steering, side shift steering today. I'm sorry that I cannot show you the films because I think it's an important part of the robotic. The robotic world is not only the small machines. I think we have to include big units and think about that, and maybe talk later about that in our ongoing discussion, where you have tractors self-propelled, like I said before, and machines behind them, which are steering the implements. Another camera system we work with, where you have a camera sitting beside the tractor and looking towards the cultivator. I show you very short the elements of this: a mobile app, a display, a hydraulic cylinder in the lower arms, and valve, and a plate which is mounted on the cultivator. So the camera is looking at this plate and the plant row and identifying the steering situation of the machine. Here you see an image of a robot with finger readers, very important part for us, and they're running hectare by hectare or acre by acre at the moment in California in the Nayo machines. To finalize, we started as a very little company. Today we are 30 people, and very excited in our new projects, which are coming up, including new in-row weeding tools and a new business model for us is to sell all kinds of weeding tools to other robotic companies, which I think, and I think René can confirm that there's a lot of, it's very important to understand what the farmers really can use and what they cannot use, and to adapt the tools to their local conditions. And that is something we do a lot and know a lot about it. Okay, thank you very much.
Perfect, because yeah, no, that was a really straight journey through the last 20 years, and it is really there are some really good questions we actually may arise in the discussion. And for the discussion, I want also to welcome Arno Ruckelshausen as a next guest. Arno Ruckelshausen studied physics, so he's the only one in this group not coming from agriculture, but very warmly welcomed. He worked in industry, and since 1991, he's teaching and doing research at the University of Applied Science in Osnabrück. And there he really focuses since the mid-90s on digital farming. So at that time, nobody knew what digital farming is, maybe, but he's working on field robots and sensor systems and data processing. He's also co-founder of the Agrotech Valley Association last year in 2019. And I have a really long list of projects he was working in, he initiated, and some products coming out. Some would even call you godfather of digitization agriculture, maybe, who knows? So, Arno, we were listening to the two really some kind of different companies, the FarmDroid very young, dively stepping into robotics. And on the other side, Kult with Christian, who really step by step got into this technology, coming from classical mechanical reading, and still is in this job and offering his experience and tools to guys who develop robots. So what is your impression? Will we see in the next few years, 5 years, robots working in the fields all over Germany somehow?
Yeah, thanks a lot for the introduction. Because of my lack of knowledge in agriculture, I always look for friends to make a project together and to learn about agriculture and interdisciplinary aspects. So thanks a lot to René Jürgensen and Christian Kirchhoff for the impressive presentations. And as Christian is pointing out, it takes some time. And also, we see from research, it takes some time to have robust solutions. And so we have, as it's pointed out, there are products, yeah, from both companies, and it's a long way. So my question would be to the companies. Okay, of course we can discuss the legal situation. Yeah, we can discuss it. But let's say the legal situation would be okay somehow. Yeah, and let's assume, as we have seen, that the robots work perfectly. So we have seen the movies. Also, we are now starting working with the Dino and the Oz comparison with tractor implement on our farm fields. So see what's going on. Now, assuming that the process is perfect, the weeding, assuming that the legal situation is okay, do you think you will sell the robots? Because René is pointing out the robot can be left on the field. If the robot is left on the field, is it still there the other morning? Do you have restock stations at the field? If the farmer buys a tractor, all the infrastructure is okay, well known. But if the farmer buys a robot, what to do with the robot? What is remote service? What you have smart fences? What is needed that these robots work in a large number at the farmer? What do you think? What are obstacles? What has to be solved? Let's say excluding the legal things, it's well discussed, and excluding that the robot worked fine, so you can see the benefit. It's not too complex and it's not too expensive.
So maybe I would say it's a question about how really to integrate such kind of robot in my practical farming system where I did not work with robots before. So now I'm working with a sprayer system and a tractor. Different employees are sitting on them and driving them. Now FarmDroid or Kult is coming, selling me a robot. What to do? I repack it on my farm, and then what to do? Maybe René, question to you.
Okay, I think this was a very long but good question that Arno gave us. I'll say that already this year we have proven some of the benefits And the farmers have actually proven that they're ready to adopt technology, that they are actually first movers in overcoming these challenges that we have in farming of using a lot of manual work to weed, especially when we do it organic. In terms of the setup, yes, the robot can be put on a field and left there for the entire season, but it can also be moved with the tractor between fields to optimize the utilization so the farmer gets a better business case out of it. The more hectares, the better the business case. There are some practical mitigations. So geofencing. Our robot is hooked up to an RTK station, which is specific to that robot, and only we can set up tunnels. So if you take the robot off the field and steal it, you cannot use it because we can protect against that, and we can track the robot. In terms of integration into the farms, I think it's important to recognize that even though robots are automatic and autonomous, it still requires some effort because it's machine. So we know the agricultural environment is very hard on the tools, there's wear parts. So the same attention you will give a tractor or hoeing equipment, maintaining it and looking after it, you need to a robot. So go out there in the morning, ensure that seats and that the wear parts are okay, and visit it during the day. But we're actually developing a remote support center to make it easier for the farmers, so we can overlook them and on an exception-based level. So if there's something that's not running as it should, we will get a notification and can support remotely. And the idea is to solve any problems before it becomes a burden for the farmer. So we can help them take a part of the service away. The whole idea is that from the seeding begins, after preparing the fields, then it should be able to run for the season. And then in the autumn, after the autumn season, we can both do for some crops spring season and autumn season. Then we have to give it the big service so it's prepared for next season and ensure we store it in the right way, inside a barn preferably, so we are ready for the next spring. So there are some things that we need, and boxes we need to tick, and maintenance as you're used to on your tractors for it to keep running the year after year. Did I answer the question fully, Arno, or there's any follow-up?
So most of it, I would say, before Arno, before you answer, I will really ask also our visitors or our audience in front of the screens to really put in questions from your side to the Q&A tool. They do already, I don't see it. So we have already some question online. Arno, maybe you can react on René's comment, and then we allow some question from the audience.
Okay, I think these are nice aspects you have implemented, and the remote support center is very important for these kind of things. Before starting the robot, do you check if I think there were also questions from listeners. Do you check if the field is ready for autonomy? If it's hilly, stony, whatever? So
we have specifications that the robot is designed to run within. But we have distributors in Germany who will visit the client or take a conversation with the client about the conditions. And there are some conditions that we cannot meet. So if it's above slopes of 10 degrees, then we would not recommend a robot right now. But otherwise, we can run in many different conditions. There's also something to evaluate. Are we doing low tillage farming? That is harder on the tools, so we need to have a good discussion before. But I think we have seen we have had challenges coming to new markets, but we also seen very good results this year, and that is what we are learning from and want to continue improving so we can fit most farms in the future.
Okay, thank you.
Okay, we have a small technical problem here, but still, Christian, you were really working on all kind of fields. So is it still the question for traditional mechanical weeding tools when it comes to fields above 10 degrees of sloping and so on. So are there those traditional working tools the better choice, or do you see there as the same problems as well?
I would ask the question a little bit different or explain it a little bit different. I think when a robot is coming on a farm, the farm has to make a step towards the robot as well. Very often you cannot just implement the robot in the farm and continue nearly with everything like you did it before. You have to organize your farm, you have to find out the fencing, you have to prepare your field in a way that you can work with your tools without problems and so on. So in principle, I think robots can work in many fields, but they need optimal conditions where you need no direct surveillance, or you need a very good security system to make them stopping if there's any trouble. That's an important point where I think many people, and I think Arno will work on that a lot, control of the tools is a very important point for the robots and for the future setup on farms. I want to say one thing about small farms. I have a lot of experience what's going on in France, and there's a total different development. There is many small farmers buying small robots. They are strongly supported by the government, that's right, but they are very open to invest. So I would not say that small farms are not interesting for robots. It's an interesting tool where you can have running your robot beside you, working in the field, have your robot doing a stupid job for like running up and down the row, and you do something like checking, harvesting, whatever.
So perfect, thank you for that. So we will now have some questions out of the audience. Alexander.
Yes, please. There are questions about the level of investment. So, what do I have to invest to have a robot, and also how high are the cost of maintenance? And is it useful to use a robot on a half a hectare's field, or do you need bigger size of fields? That's one of the questions, please.
Should I start, or Christian, would you have the word?
Yeah, you're free. Go.
Okay. I would say a half a hectare, that is not enough to carry a business case. Depending on how fast you want the return on your investment, I think from 10 hectares and above is where you have a feasible business case. If you use it for 20 hectares for spring season, let's say organic sugar beets, and autumn season where it could be rape seeds, it could be other things of your imagination, then the business case is, we say, return on investment is less than 2 years.
Okay.
Maybe I can give you a bit about the pricing. Just I think FarmDroid is something like 80,000, right?
Oh no, no.
No, sorry. I know our robots are between 25,000, small ones, and big ones with in-row equipment like 125,000. So yeah, that's the price range.
Yeah, we only have one model now, which is for the 20 hectares per season, and that has been sold in the spring for 65,000.
Okay.
So maybe Bea, the question to you. I know that you had some field days this year also with robots running. So you checked them very in detail and saw them working in the field on different fields and different crops. What was your experience? Also the feedback from farmers in your region? Also a lot of vegetables are grown, but also normal agronomy farms with wheat and rapeseed and so on, and sugar beet are in place. So what is your experience when you looked on those systems? having in mind the structures in your region?
Answering that, I can confer to what Christian said. I really have to confirm his opinion, and that when the robot comes to a farm, the farmer has to make a step towards the robot. We have really all farmers are quite interested in the technology, and they at first they can imagine to use it on their farms, but yeah, you have to imagine when you start what you want to do with it. I think there's labor on the field where it's okay to use the robot, like planting or like the crop care, the mechanical weeding, and there's still work to do, like the heavy soil labor, the heavy tillage, that the robot is not suitable. And the experiences, yeah, when you make experience with these new automatic systems, we also see parallels from the time when the first in dairy farming, when the first automatic milking systems were established. There were a lot of farmers, really good dairy farmers, who implemented the systems, and they didn't get it with this automatic system. And yeah, after a few years, they weren't dairy farmers anymore. And that's the same thing now with the robot, and that maybe every farmer is interested in it, but can't handle this system.
Okay, so I see that we do have some question from the audience. Alexander.
Yes, there is a question just in that direction. So one participant says, all fields look very clean in your examples, but we have systems with crop residues on the soil surface to save moisture. And how can robots work with that?
Yeah, from now, it is really the case that crop residues and so on, and stones like that, technique till now doesn't seem to be fitted on these conditions. But I think this will only be a matter of time when also the robots are able to meet these situations, I think. I don't know what do the companies say. I think it would be cool if we could meet the implement technologies from Christian's company Cult with this genius drivetrain components from FarmDroid, from René's company, and then would fit in a system that would work on every ground with every crop residue. Yeah, I think that would be the great marriage.
So Arno, what about your projects? Is some of your projects, of your research projects, really focusing on such kind of topics, or is it more on the basic guidance and steering systems of robotics?
Oh, we have a weed control. We have this research platform, BonnyRob, and we put in a multi-stamp. That means we have imaging systems, as we have seen, which are major technological key elements for detection. And then we have machine learning included. And in the future, we see, okay, if we know what kind of crop or weed is there, with some additional knowledge, we might even say, okay, we have bad weed and we have good weed. Good weed might help the crop for better growing. So we can do a much smarter weeding with this knowledge. And this is also the research, to have the mechanical weeding, to have the knowledge, and to really compare that. And also what René is saying, the robots could work slowly. They work careful. And if they work 24, yeah, and if there are swarms, you can go to the economical way. So you have really a good thing with these robots and with these digital technologies to combine economical and ecological effects. And I think this will be the future economical success.
If our audience is the same opinion. So I know that there are some few questions from Alexander still.
Yes, we have a question from Northern Ireland. How do the panel see as the 5 biggest obstacles in making mechanical weed control work as efficiently as chemical control?
I could
What
not
are
understand.
the biggest obstacles?
Weeding, directly comparing mechanical weeding to sprayer systems, I guess it's a quite difficult case. Who may answer this question or somehow frame it in a set it into a frame?
I can take a go at it.
Yeah, perfect. The most
First of all,
one.
it's a very difficult comparison, because on the conventional chemical fields, you used to see a very clean field under almost all circumstances, where the mechanical
now he's off
some
again.
weeds.
I guess now it's working again. Start again.
Okay. Yeah.
Okay.
I'm unsure how far I got before the sound dropped out. Let's say for mechanical weeding, and many organic farmers, they are used to having a bit of weed in the fields, and it requires support from manual hand weeding. But our objective is to remove as much as possible, but very close to the crop, it can be difficult to move it mechanically without harming the crop, especially in the early growth phases. Our take on it is actually to start weeding before the crop have emerged to the surface, to get a head start for the crop. So basically, weeding between the germinated seed and the soil surface, that is one measure. But still later in the season, getting really close to the crop, that is without doubt the most difficult part of mechanical weeding.
Christian, from your point of view, with 30 years of experience, will ever mechanical weeding turn over the chemical herbicide application?
From when we talk about robotics, I cannot see a big difference if it is chemical or mechanical. When it comes to the tools, yes, we have to adapt the tools to the soil conditions and the type of farm. We should not forget that there's also chemical robots which spray chemicals, either spot spraying, or I know from California there's robots driving in orchards, driverless sprayers, self-propelled sprayers more or less. So there's other type of robots we are concentrating, and my company is concentrating only on mechanical weeding. So I think robots are open for all kind of implements and are not really limited.
So understood that. Alexander, do we still have questions from the audience? Maybe a last one?
There are a lot of questions. I will take the last one. Is it already possible for a robot to inspect his own work so it can adapt to the conditions of the field or mechanical breakdown of the attachment, so it can really work by itself, by controlling its own work?
Very interesting question.
Very interesting question. So maybe Arno, maybe you do have some look into the future about that topic.
Okay, you have in classical agriculture machinery, you have control. For instance, if you do plowing, we have systems which measure the soil ground with 3D imaging before and after. So this quality checking, I think, is very important. And I think we will have not only one robot on the field, we will have swarming. And it's not only the case that they could do all the same job, they could do different jobs. And they could check the quality. For instance, we have made a robot swarming with 2 bunny robes. One is measuring the moisture of each plant, and the other is giving an amount of water to this plant. So you have you could have a checker robot, yeah, check robot for this, and combine this information. I think this is a very important thing, because the robots are really autonomous. It's not like in automotive where still a person is sitting there. I think we're on the way. Yeah.
Yeah, thank you for that. Okay, looking at the time, so we had about 30 years in an hour, so to say. I want actually to wrap it up somehow. I got really some nice aspects out of this talk. First thing is a very young company working directly first step into the robots compared to a company since 30 years in reading, working step by step into the new technologies, but no different opinion about mechanical reading or in comparison to chemical reading. So there is a very good development in the future. We can soon, I guess, we can soon see more and more robots working in the field. If there are in that design like FarmDroid have it, very autonomous, not even similar to any tractor, or some tractors working autonomously, like maybe Christian is supporting with different sensors equipped to the tractor. That doesn't matter. This has to fit to the farm working with. And the second thing is what Beat said in the end. It has to be the first step from the farmer in direction to the new technology. The farmer has to be open for new technology, giving the technology the chance to adapt to the field as well. And nobody can expect that out of the box, everything is working perfectly. So also chemical spraying is at the moment still the top technology to have a really clear field. Is that necessary in future? Question mark. And also chemical spraying had a long history, decades of new developments. So robotics is quite new, but already very close to practical farming. I want to thank you, Arno, René, Christian, and Beat for getting us this knowledge and being member of this group of discussion. Thank you for that in all directions of Germany, southern Germany, Denmark, Osnabrück, also Bavaria in the eastern part of Germany, the eastern Bavarian part. Thank you for that. And all the guys listening here or had not the whole session here, all the videos of this, the recordings of this panel will be later on in 1 or 2 days offered on the webpage of DLG, and also look into the topics of DLG Digital on the webpage. There you will find a lot of different topics on plant protection, cropping systems, and also fertilizing and so on. There is a big amount of new information and methods for crop production. Thank you for that, and hopefully also to you guys. See you next year in June in person at the DLG-Feldtage in northwest Germany in Elbitte, where it had 70 millimeters of precipitation this weekend. So I'm quite glad to be not there at the moment, but this is a good conditions for next year. So soil will be wet for next year, and the crop stands will be perfect for mechanical weeding. Thank you for that, and goodbye. See you soon.